When we do the mass carbon balance test, this is a test that is approved by not only the Australian standards, but all the other EPA standards. If you go to any type of lab to do any type of test, they use a carbon balance equation to be able to do that. So when we do our mass carbon balance test, we are still using all the same laboratory tests that we would do if you took it and had a dynamometer done, or if you took it to the EPA and had the emissions read, anything those kind of things. They all use the mass carbon balance formula in one way or another to be able to come out with the equations that they have. The one thing about the mass carbon balance test and what we do is we'll go in and we'll take the specific gravities of the fuels, we'll take the temperatures and humidities, and then our engineers will read all the exhaust gases coming off of the vehicle. Then you run out, you go out and you run your base, that's your baseline. Then you go out and you run a treated segment. We maybe would like you to put 5,000 miles on it with the treated segment. You come back and we run those same type of tests again, and we will compare specific gravities of fuel and temperatures and everything. So everything's back to balance. So you're eliminating the problems with wind or weather or how a driver feels that day or any of those kind of issues that will come with that. And then you can get this mass carbon balance equation is a formula that shows you the emission savings as well as the fuel savings.
Carbon mass balance test procedure is utilized by just about everybody. It's a function, it's an intricate part of just about every test procedure that's used. The 511 test, California Air Resource Board 511 test is a carbon mass balance test. The HFET, FET, and the Federal Test Procedure, FTP, it's a very authentic, a very reliable source of testing because no one's driving mad. No one's driving on low tires. Nobody's driving on worn tires. Nobody has to worry about weight and differential in weight displacement, or high load versus low load, wet terrain versus dry terrain, what type of fuel they're actually using. Is it comparable to the fuel that they got last time? Probably the single most astonishing fact is the change in their fuel from test to test. They have a hard time believing that fuel changes that much. There's the assumption out there that everybody makes fuel the same. I wish that were true, but it's just not true. If you're familiar with chemistry or mathematics, in root algebra, whatever you do on one side of the equation, you have to do on the other side of the equation. You always balance the equation. In chemistry, you balance chemical formulations. Carbon mass balance is nothing more than a balancing equation. I take a sample of the fuel and I measure temperature and specific gravity, and I calculate both the baseline and treated fuel samples back to a level of stoichiometry and a specific temperature. So I can actually see if the fuel, the BTU of the fuel changed during the course of the test. I then allow the engine to stabilize. By allowing the engine to stabilize, that means that the engine temperature, oil temperature, things of that nature are at optimal levels. I can guarantee that by inserting a temperature probe into the stack of the vehicle to monitor exhaust temperature. I also insert a magnehelix into the exhaust so I can look at cross-sectional variations in flow from the engine. So I take a cross-sectional look at the exhaust with the velocity indicator. The carbon mass balance equation, it calculates and compensates for changes in velocity. So if I'm at 1500 RPM and I have a velocity change, the equation compensates for velocity change so that we're looking only at raw carbon. So I know I am at exactly the same load every time. Every time. I use data from NOAA so that I know what the barometric pressure is, what the temperature is at the time of the test. So whatever's in that fuel tank has to come out that stack in one form or another. It has to. And when it comes out, I look at the form that it comes out in. And I calculate the change in that form by molecular weight. That molecular weight creates a performance factor in grams per second, and then I determine the differential between those two performance factors. And that shows either an improvement or no improvement, one of the two.